All right, welcome everyone. So today's topic title is World of Industrial Automation, and the subtitle I chose deliberately as Rise of the Machines. And whenever we think of Rise of the Machines, the image that comes to our mind is of Terminator or Matrix or Robocop or something like that. The interesting aspect is today's presentation we're going to discuss about this kind of an image, which we have to reintroduce in our minds, since we don't see this very often. So I don't know, many of you guys who might be working in manufacturing units with automated technology, you might have seen, but but in person, for an analyst like me who sits in a room and reads annual report, I have not seen a robot in person. So the genesis of the idea came when I was presenting on the semiconductor topic, and in that, every company I was reading about, they spent significant amount of money on automating their processes. And there's a reason for that, because it's a very precise process, and you cannot have human beings do the process by hand. It's way past that scale where humans can never do it. Even machines need special machines to aid them to do the work for assembling and packaging the microprocessor chips. So when I thought of this idea, I said, okay, this is prevalent in one industry where it is almost 100% automated to the extent that now machines are making machines. What about other industries? What about the scale of automation in other areas of industrial activity? So this, just to give a context for today's presentation, uh, the whole idea behind industrial automation is not very new. It has been called different things in different times. So it's a 300-year-old topic in a way, right since the beginning of the Industrial Revolution 1.0, where automation today is basically mechanization at that time. We'll also take a look at the evolution of industrialization across the past 300 years. We'll also see what exactly automation means and various applications of automation. And we'll see some of the different business models that exist specifically when it comes to automation and robotics. We'll also take a brief look at what Industry 4.0 means. So Industry 1.0 was mechanization 300 years back, and we have come to Industry 4.0. It's a long journey, but it's interesting to see what it is and what are the myths and challenges that people face. Zoom audience, can you please keep your microphones on mute? Thank you. Also, more importantly, why now? I mean, why is this time is the right time to understand the context of why industrial automation matters, and also what it means for India. And okay, I put the point there what it means for India, but I actually have more questions there. So maybe some people in the audience might have some answers which I also can learn from. So 300 years back, when handlooms were prevalent, people were working with their hands and manual labor was prevalent in factories. Uh, Something called a steam engine was invented, and it's debated who invented it. People attribute it to Mr. James Watt, but the whole idea of the steam engine created mechanized power. So you can actually burn coal. So 300 years ago, when the Industrial Revolution began, the idea of steam engine was very new, and we could now burn coal, boil water, create steam, and channelize it in a pressurized chamber and create motive power by burning that particular fuel. And this was very new at that time, because before that time, all the experiments to create the steam engine or the governor, which was used to run the steam engine very efficiently, have exploded on people's faces, literally, quite literally. So once they figured out how to not make the machine explode, they figured out, okay, what else can we put this in? What else can we plug it into? The most obvious answer was put it on wheels and see where it goes. Make an engine and connect it to that. Try and mechanize using some form of a power loom machine, a small loom, and see if we can move something. And once the movement was achieved by burning some other source of fuel, we realized that this can be scaled. And within a matter of 25, 30 years, you had factories coming all over the place making different versions of steam engines and implementing them in the factories of textile mills where people were using hand looms. And they became power looms, not with the electric power, but steam power. And naturally, at that time, people who were adept at using their hands to use these mills, they lost their jobs. Their jobs got displaced. So in the first 70 years of industrial revolution, which is not very well documented, but whatever little bit documents we know from that period of time, was a very hard period for people to adjust to this change, which came in very suddenly. So an entire class of people suddenly got displaced because of mechanization of the power loom. And at that time, so this image represents that particular movement. They are known as Luddites, led by a person whose name was actually Luddite. And they are here smashing the power loom with hammers because they want their old jobs back. And today, the connotation of Luddites is used in such a way that it mentions of a technologically unsophisticated person. But to be very honest, it's just a person who is scared of losing their livelihood, and they are trying to get it back by destroying the machine that displaced their livelihood in the first place. So this is a very thorny argument. This is not something we take very lightly, even today, when we talk about automation and technology and job loss in that context. But it has been an argument which is visible in our capitalist history for the past 300 years. And ironically, we have all benefited from the productivity gains that most companies have learned to achieve by using motive power. So just to give a quick look of what the industry 1.0 was, it was the use of steam power to create motive power. Then came electrification. So I don't know if you have seen the movie about Edison versus Tesla and all that power wars at that time, Westinghouse and Edison. Once the electrification was achieved, grid power supply was available through various means by burning thermal power or hydropower or whichever means. Electrification also reached all the factories where previously people were burning coal locally to create steam power. Now they could actually get a grid power connected and power units were used to make the same thing. And if you look at the scale at which Ford Auto Company grew during the early 1900s, is because of the implementation of electrification in their plants to create an assembly line, which is a management system they incorporated, and scaled manufacturing, and which became the global prevalent standard of manufacturing, at least from the Western countries. And over a period of time, I think next 60, 70 years, we saw the advent of robots. So 1960s, 1970s was the advent of automation, robotic technology to be used in conjunction with specific processes and making sure that robots can do the job better than a man in a more precise manner, repeatable manner, scalable manner. And now we have reached the threshold of Industry 4.0, which we'll discuss a little bit later. But the whole idea is that can a robot automatically learn, sense, detect, and perform a task which otherwise could have been programmed into the robot? And what else can the robot do along with that particular task? So the unique ability of humans when we are put into situations is that we intuitively figure out how to optimize the thing to do it in a better way. But a robot has to be taught in the form of an algorithm, has to be trained in certain ways so that they can learn in that particular manner. And that's the challenge which is being figured out by Industry 4.0. And also with the use of sensors, robots are far more intelligent today in terms of aware about their surroundings than they were when they were first invented. So why is this race to improve productivity? And it's a very important question to ask, especially from an investment point of view, because we thrive on productivity. We are probably slaves to the metrics of ROC or margins of the companies over a long period of time. We track them, we obsess about scaling those margins over a period of time as the business grows. So we are in a way slaves to productivity, and also the industries which we invest in are beneficiaries of any productivity gains that they achieve. So the whole idea behind reducing time to market is essentially no company competes in a vacuum. They are working against time with their competitors, where somebody can scale or automate a process faster than them and they can capture market share faster than them to meet whatever demand is there. Also, when you are operating at scale, it always helps to reduce the amount of errors that are there in your manufacturing process. If 10 out of every 100 items that you ship out of the factory have some defect, they will eventually come back to you, will increase the reverse inventory that you have to manage. You have to also provide warranty support. You have to provide a repair to the person who has bought it. And the whole supply chain gets mucked up with the reverse process. So it's better to reduce errors at the get-go by creating a better quality manufacturing process and try and minimize it. So over a period of time, we have designed standards to reduce errors and which are implemented across manufacturing units. So also we are obsessed with, as consumers, obsessed with new things. We want the new iPhone when it comes out. We want a new computer when it comes out. We want some of the other electronic gadgets, some of the other things that we always catch a fancy of. Our upgrade cycles in many products have increased quite dramatically to meet that kind of a demand at scale. So one interesting byproduct of the industrial revolution is the creation of a middle class, which over the past 250 years has been able to consume services and products at a rate we have not seen before in history, ever. Because nobody had that kind of money at that time. before that time, and nobody was producing at that scale to meet any demand which was even created. But with globalization, supply chains becoming no longer remaining local, people are consuming ever more than they otherwise could. And to meet this scale of demand, we also need to scale up the manufacturing capacity. Another interesting aspect of productivity improvement is also managing the extreme cyclicality in labor markets to avoid getting whipsawed by the labor wages suddenly spiking up in local areas when there's a skilled labor shortage, or even the market cycle. So if you get caught up in the bad cycle, you have capacity, but the market doesn't want your products anymore for a while. You need to manage your productivity in that sense also, so that you are going to manage your plant with the optimum resources and scale whenever required and downscale when not required. Also, when we look at some of the examples of productivity improvements in companies, there's always this debate about capex versus opex. So any human being which is working in the factory is essentially an operating expense as a wage bill for the company. But a robot which is bought, it's a capex which will last for a determined amount of time, which can be depreciated over a period of time. And the robot's maintenance as a whole for the factory compared to the factory's output might be much smaller. So automation from a capex versus opex argument is also a relevant argument which many companies prefer to have when they are thinking of getting productivity gains by automating. Also, interestingly, when you have people working in a facility, you need to create other facilities around that area to make that area occupiable by human beings. It needs certain kind of lighting, certain kind of cleanliness, ventilation, etc. But when you have an automated plant, you might be able to optimize your per square foot of the plant in terms of getting more robot machines fitted in, and they can do the same work. This is not always like to like comparable, but it's one of the possibilities. When you automate processes, you can actually get higher per square foot yields than otherwise you could have gotten with humans around the plant. And also over the long period of time, we have seen, so I mean, if you have read fiction from the 1900s or 1800s, if you read Charles Dickens, the kind of conditions people were living in and working at that time, you will realize that those are not human conditions. Those are conditions where people were just trying to meet their ends by working in any kind of a workspace which was very hostile to their health as well as to their mental health, because their hours were not fixed, they were not having shifts which are predictable, and they were working in harmful environments. So imagine over a period of time, with workplace safety issues have been resolved, you have industries which are far safer for human beings to work. At the same time, if you are replacing that particular job with a machine, that job does not need to have the same safety standards as a human being around that machine has to be. So some jobs will completely replaced by machines in the way where they can operate in hazardous environments and still do the job. Now, this can be a hazardous environment can also mean an astronaut losing his job to a robot over a period of time, or a bomb diffusing mine which is run by a robot a mine diffusing robot is also used instead of a human being trying to diffuse the mine on his own, or working in coal mines with a automated mining equipment, or even harvesting crops on a large field where human beings are not available to do that. Kind of conditions which are very harmful for humans to toil in a long period of time can be easily achieved by automation. Some of these gains are natural. Over a period of time, they have accelerated their pace, but at the same time, we have seen the flip side of the automation is that there's a job loss, there's a anxiety in the community, and we will see some of these topics going ahead. So one show I have to recommend all of you, you have to go on YouTube when you have time on the weekend and search for Industrial Revelations by Mark Williams. Now, this is a 4-series Discovery Channel show where Mark Williams, probably one of the best history teachers anybody could ever have, walks us through the entire stages of industrial revolution, right from the invention of the steam engine, from where it was invented to the debate of who invented it and how it was implemented across different industries, and the trickle down effect over the next 50 to 100 years on the life in United Kingdom. How the people changed their lifestyles, how the middle class came up, how suddenly consumption of certain items increased because there was enough supply now to meet demand from faraway places. Suddenly you can travel in a car from long distances, carry load in a long distance without relying on animals to do the job. And in harsh weather, which can be in the winter in UK, some of these things were achieved by machines at that time. So it's interesting to watch this series to get a visible context. And it goes through a lot of detail to understand how these things were made. At the same time, the impact they had on the local cities. So there were coal towns, there were steel towns, there were textile towns, and how they evolved over a period of time to become something totally different. And that's an interesting transformation to see, because that has happened in several communities across the world. So let's get to the topic at hand and define what automation is. This is not my definition. This is from a very popular definition online. So automation basically means use of various technologies with predetermined processes to reduce human manual intervention for repetitive tasks. That's a key word here. So in repetitive tasks, there are some tasks which are done better by a machine than a human being, whereas a human can also do multiple repeated tasks in a sequence which a machine may not be able to do intuitively. So automation can be on both fronts. But before we understand automation at scale, let's just take a step back and look at a typical manufacturing enterprise in the modern day. We're not trying to recreate the industrial revolution enterprise. It has changed quite dramatically. So this is a very, very bird's eye view of a modern factory. Over here, you have the centralized ERP system, which is a software usually, and it is connected to all the enterprise tools and capital constraints which are provided to the system, which is how much money you have in working capital, how much inventory do you require. All those decisions are already made by the enterprise and fed into the ERP system. You have customers on the other end who are relying on the ERP system. It can be intermediary customers also, like dealers, distributors, or directly end customers who get a portal login to see whether product is shipped by the company or not. And you have vendors here who are also plugged into the ERP system, who are mapping what demand is from the customer, and they will ship the product accordingly based on what the ERP sends them as information. At the bottom over here, you see typically three main areas. One is the R&D area, which is responsible for product development. They will create the product and they will tell the manufacturing team to build a product as a prototype, and then for a finished good at scale. There's a warehouse which has incoming raw material, outgoing finished goods. And you have factory, which is in turn having several production lines for different facilities, different items they are trying to create. It can be an assembly unit, it can be a manufacturing unit, it can be all sorts of things. This is a broad representation of a manufacturing setup. Sorry, something broke. But when you zoom into all these areas, so one thing that the R&D team does product lifecycle management. And what that means is they are aware that what product they're shipping right now may be an obsolete product. They have to update it. They will design a new product. They will do tests. They will run tests. They will have small batches created. And they will also figure out a way to redesign the manufacturing process to make that same product more efficiently. The factory has a distributed control system. What this does is it essentially connects all the machines to one centralized system, and the supervisor or the plant operator can actually manage each of these machines and see what is happening where. And this can be a manual intervention by the supervisor at the DCS level, or it can be an automated process which is pre-programmed to run the way they have designed it to run. And finally, we have the warehouse management system, where the warehouse may do incoming, outgoing of inventory and finished goods. And it can also be automated, or there can be robots used over there as well. But even though it might be a human process, it still requires a input or output from the ERP system to tell him what to do at what times. So again, just giving another approach to the same problem. And these, don't worry, I'll explain all the acronyms to you. So PLM we were aware of is the product lifecycle management. SCADA is basically supervisory control and data acquisition. So this is basically a front-end software which is on top of all the other manufacturing software. This is how a SCADA system looks like. So in the typical SCADA system, you will see where which machines are, is the power supply okay or not, is the machine functioning as per its optimal requirement or not. So all these systems are available in front of a plant operator or supervisor, and that is then internally connected to the distributed control system. Now what happens is these DCSs are connected to several PLCs, and what these PLCs are is programmable logic control. These are basically small devices which are doing a specific job. So for example, a simple example would be the water tank in our societies, which has a PLC connected to it, and there's a pump attached to the PLC. The PLC's job is to identify when the sensor tells that the water level has dropped to turn the pump on. Once the water level reaches a certain level, sensor will tell the water level has reached the ideal level and to turn the pump off. The PLC job is simple to turn on and off based on a external input given to the PLC. Now the PLCs are actually very strong computers with very simple logic written into them. These chips are not like normal computer chips that we have. These are rugged chips, and they can survive in hostile environments, in humidity, temperature, you don't mind. And they're designed to work in a very specific and controlled manner for doing one or very few tasks. And imagine there are several of these PLCs. So one PLC will be responsible for moving the conveyor belt. Other PLC is responsible for a robotic arm to pick some product up and keep on the conveyor belt. Third PLC will be there to pour something into some vat and do some process, whatever. Whatever the manufacturing plant is, there will be thousands of PLCs running around the system, which are controlled and organized by the DCS and visible through the SCADA as to how the operations are going. And they are in turn connected to the warehouse system to put in input to the process. And ultimately, all these PLCs can be also linked to robotic controllers. So either a human being can stand there and manually assemble and build something, or a robotic arm or a robotic system can be put in with a robotic controller, which can do the same thing when the PLC instructs it. So in a human's case, there will be a visual indicator, or the product might just come in front of them in the conveyor belt. In a robot system, the robot will have laser sensors or a camera system in place, with which it can identify what the action is supposed to be done based on a pre-programmed input. So this is how a basic manufacturing setup works. And although it doesn't sound very exciting, I find it to be very exciting because there are so many pieces where people have written management theories about how to optimize all these processes. So each and every company will have their own manufacturing process, will have their own philosophy behind how to organize this particular thing to make the most efficient use of manufacturing tools that they have, including the softwares to use, including what kind of robots to use, what kind of PLCs to use. And there's a whole host of business that we can talk about later in the business side, business slide. But the whole idea behind this whole process is when we see that it can be routinized to such a small, minute level at each task, we always come to this question whether automation is versus humans or versus something else. But we tend to sometimes forget while we are looking at this argument that automation or mechanization, to be very precise, has been happening for thousands of years. So where a human being would have been doing this plowing of a field was replaced by an animal, and the brute strength required to do the work was given to an animal who has far more strength, far more stamina, can do the same tasks longer under harsh conditions. Then we figured out, okay, once we got industrialized, we figured out a machine can do this job much better and at a magnificent scale than a animal could do in the same period of time. And if the farmer could afford it, they would invest their money and create this system. And now we're at a stage where we don't require any animals. We don't even require the human, to be honest. And these kind of autonomous plowing tools are also now available. And there are, in fact, autonomous harvesters, there are autonomous tillers, autonomous field sprayers, all kinds of autonomous tools are available. People can also monitor this entire operation from with a drone camera, and the farmer can be sitting with a cup of tea and with his iPad and probably figuring out where everything is. So this is the level of mechanization we have done. Instead of replacing humans, I think we should replace it. The brute activity that a human being had to do was replaced, and probably the human was freed to do something far more superior with the intelligence that the human being has. But the whole idea behind this debate is whether this is a labor reducing technological innovation or a labor replacing technological innovation. And this argument has not been fully settled, because what may be labor reducing at some point in time can enable a gateway for a labor replacing technology. And there are so many things around us which we have probably just accepted that they have replaced labor in some form or the other. So if you have people who are 60 plus years old in your network, you just ask them about telephone switch operators and what happened to that profession. And some people would be in that profession at that time, would have been given some other job in that same company, or probably were retrenched at that time, because telephone switches became automated. Nobody requires a telephone switch operator anymore who can manually plug in the cables. Now everything is a automated technology. What about elevator operators? I mean, at one point of time, elevator operators were needed. We still find them in some buildings, but what is that job really? Even bus conductors, what is that job really? So all these kind of labor replacing things have already happened. There might be social and political considerations. We are using these jobs still now, but at the same time, we need to be very cognizant while looking at technology and automation that whether it is a labor replacing technology or a labor reducing technology, and that only is revealed over a period of time. Nothing can suddenly, so very few things. So switch of sorry for the pun, switch of the networking switches from manual switches to automated switches, that happened in a switch where people actually, there's a nice anecdote about this, where the telephone operators, they actually went on strike saying that we will not route any of the calls from the next day if you use that machine which automates call switching. And once they went on strike, nothing happened. Everything was working fine, the telephone network was working fine, and the strike itself was forgotten. From the front page of the newspaper, it went to page 6, page 7, and people forgot about it. So it's quite heartening when you see all these things, that okay, on one side technology benefits us in the long run, but people at that moment who are replaced by technology are unable to replace their skill set with something else. They face a very hard time in that particular period of time. So again, this is a very fantastic resource. International Federation of Robotics, they generate one fact report every year about the state of industrial robotics, and it's quite detailed. It's very interesting to read through. So in this recent edition of the report, which is I think 2019 ending data, they basically gave a context of which kind of industries is automation used to the maximum extent. So automotive industry, of course, we have seen most amount of videos and images of automotive industries. The car is on the assembly line and robots are coming and operating different tasks on the car, or the bare shell of the car, and different units are kept in that car. Different items are installed in the car with the help of robots. And we have seen that, which is also apparent in the chart, that it is one of the largest automation users in the world. The second largest is also more interesting, is machine automation. So anything that we produce on scale. For example, if you want to run a bottling plant which fills Coke into bottles, that entire operation can be run by a machine. You don't need a single human being in that plant. You just have to put empty bottles at one end. Sometimes you don't even need to do that. There are also extrusion machines which actually put plastic extrusion items into the machine. They blow it into a bottle. They go into the supply chain. The conveyor belt. They go to the areas where the bottle is cooled, cleaned, and they fill it with the liquid inside. They cap it, and the bottle is shipped in a carton outside with other bottles in it. So the whole idea is, even consumer technology or consumer food items which are produced and processed at scale, they also are under automation, and it's a growing industry. And also you have general purpose use in various factories where a human being is working next to a robot doing a certain task. Picking or lifting is done by the machine, and the human being just organizes the data points. General industry applications in different factories are also there for robots. Electronics is a slightly different category right now. It's a smaller category because there's a lot of complicated components which need to be assembled, and it requires dexterity, which sometimes a human being is better at. But even over a period of time, people have complained about hazardous conditions in those factories. And those assembly can also now, over a period of time, might be done by robots once somebody figures out a way to do it in a cheap manner. And these CSSR basically are service bots. So you can have bots for cleaning facilities. So I don't know if you've seen the videos of people cleaning the streets of China when the corona pandemic was at its peak. At one point, there was an autonomous vehicle, a small autonomous vehicle cleaning corridors inside a hospital, and it had sprays coming out on both sides. So these kind of service technologies are also used in the form of automation tools. So overall, we can see that industry has been using automation for a long time, and this is, I think, a manifestation that some of the industries are far ahead in terms of using automation to scale their businesses. So when we saw clearly this particular system in which a factory is organized, one business model which we know very well, and we have probably spoken in the past in FOF sessions before, is the software model. So any software which is built on top of all these systems probably can be sold in the same manner. You sell a license and you have a maintenance contract with it, and you provide a maintenance over a large period of time. And some of these softwares don't change very often. So once you are able to enter a factory, all the associated technology and software which the particular software company requires has to be bought by the customer. So software business is very easy to understand, and we will not be talking too much about the software industry. On the other hand, there are these three different kinds of business models present in the automation ecosystem. And one is the end-to-end system. So companies like ABB, which is a Swedish company, or companies like Siemens, which is a German company, or Schneider, which is a French company. These companies are known, or Omron, which is a Japanese company, they are known to provide end-to-end solutions. So they will not only provide the software, which is required to run these other tools in the factory, They'll also build and make the robots which are also used to automate and connect to the systems. So essentially, if you are starting a plant and you have tremendous amounts of money and no amount of money is enough for you, you basically can hire one of these end-to-end players and say, okay, build this plant for me. Nobody in their right mind does that. In fact, in very small cases, it happens. Usually, automation and implementation of automation technology happens at a stage manner in small batches to see how it works in different cases. Nobody suddenly says you build end-to-end system for us, but nevertheless, they provide end-to-end support and services to everyone. So it can happen that eventually a customer who has started using one aspect of automation tools from these large end-to-end providers, they will end up buying other products from them, and that ecosystem is full. Just like how we might start buying with an iPhone, then we might migrate to a MacBook, then an iPad, then AirPods, and then Apple Watches, and then we are in the ecosystem of Apple. Just like these companies work in an ecosystem of technology and products and services. Other end of the spectrum is essentially very specialized and niche players, and these are also giants. Okay, there's a slide after this. Don't try and read it. It's a tiny slide with numbers and names of companies, just to illustrate how big they can be. Some of these niche specialized companies are specialized in doing one or few things around that particular area. So one can be building robots. Second can be building components which go into other robots, like discrete components, motors, hydraulic pumps, or even small kind of chips and other things which go into them. And then there are software companies which basically use software technology to help run systems which are connected to them. So there can be open systems which are there available, or they can be closed systems which are provided by the end-to-end providers. So these are all specialized players which also operate on a similar business model, like a manufacturing unit or a software company combined. And then there are these integration players where they not only provide with consulting and how to build plants, how to operate them, and which technology to use, they also provide you with specific tools. They might be manufacturing or they might be sourcing from somebody else. And they might also have their own software tools, which will help you monitor all the plants and other things better. So this is a very non-comprehensive list of companies which I read the filings for, just to get a sense of what these companies are doing. And interestingly, if you see companies like ABB with $67 billion market cap, Siemens 133 billion, Schneider 93 billion market cap, Omron 21, Mitsubishi 46. So these companies which are listed just now are conglomerates at scale, and they have several businesses underneath them. So these numbers that we see of gross margins or ROC numbers of the past 5-year average may not be representative of the automation business. The automation divisions actually might be running at a significant profit and significantly higher ROCs. But these are giant companies, which some of them are even hundreds of years old. So it's very hard to actually pinpoint, even if you read the financial statements, to figure out which of these segments are generating revenue from the automation activities that they're doing. Whereas there are companies like Fanuc, which is a robot manufacturer from Japan, or the company like KUKA, which is a German company owned by a Chinese company, Media Group. They also make robots which are used in factories. Teradyne, which owns a company called Universal Robots, which also makes industrial robots. And Keyence, which in fact is a very interesting company. It is one of the market leaders in vision technologies. So nowadays, robots are equipped to see what they are doing, and they can actually change their activity based on where the product is. So for example, if in the factory conveyor belt, the product has to be placed here for the robot to operate, but the product moves a couple of millimeters ahead, the robot can see it, adjust it, and do the activity by themselves without losing a step of the process. So the whole idea is some of these companies, like I mentioned, follow the same business models. Some of them are end-to-end providers, some of them are specialized providers, some of them are integration providers. But it's interesting to see the names of companies, the names of countries here. So when you look at where the IP actually comes from, it again, like the semiconductor industry, comes from a very few developed countries. USA is one of them. Some countries in Europe, like Germany, Sweden, Denmark, France, there are a few of them. You can see Japan is a big source of IP for many of these automation tools. And I think Japan also has a culture of automation over a long period of time. There's a innovation involved in automation tools over there. And lastly, the most interesting thing is China, where out of nowhere, since they are an industrialized country and they require industrial tools to improve productivity of their manufacturing operations, they have somehow been able to create some companies out of this, which are Chinese companies started on the basis of foreign technology. But it's a massive scale of a business which is operating all over the world. But unfortunately, the IP resides in a few locations. And Some of the new open tools are challenging that, but it's not at the scale at which you can dislodge some incumbent players at this point in time. Just to give you a scale of the annual installations of robots over the past almost 10 years. This is again from the International Federation of Robotics report, and this is thousands of units. So you can see clearly globally, Asia, which is mainly China and some other developed industrialized Asian countries, they're actually the largest consumers of incremental robots which are sold globally. Whereas the previous industrialized nations, which is Europe and Americas, they are not consuming as much, but they're still growing. It's not a declining number, but still growing at a much lower scale. This is the overall number. In fact, in 2020, there were a little less robots sold globally, obviously because of the pandemic, probably. But the trend was interesting. It'll be interesting to see what happens in 2021 when you don't have the labor available to you, and what are companies doing? Are they automating more? I think I'm more interested to see the trend from the next couple of years to see does the installed capacity of robots increases quite substantially from here. But this peak was interesting to see. This particular trajectory was interesting to see that robot adoption has grown so much across the world in the past 10 years. It's fascinating. And if you look at the installed capacity of robots in 2019, again, auto dominates along with electronics over here. This also includes assembly robots. So the previous one we saw were for creating the electronic components and miniature parts. But this is essentially the assembly part also, where robots can assemble larger electronic items as well, like TVs or refrigerators, which are now electronic gadgets. Metals and machinery is obvious, where you have large factories where human beings cannot work or operate in those high temperatures or noxious fumes. Machines can do a much better job in pouring a molten metal or stamping metals into accurate shapes. Food is another interesting category. In fact, if you are even tracking the ag tech industry, which is agricultural technology industry, you will see a lot of innovation happening, not just in the larger items, which are harvesters or tillers or spraying technologies, but interestingly, there are also weather sensing technologies where drones can fly and check over a large patch of land where the weather, whether water, humidity, and moisture levels are same or not. They can also do temperature analysis of the soil and see where the temperature is not optimal for the crops to grow. They can even have robotic arms which are operated on autonomous bots to pick fruits and vegetables from the field, which otherwise is a very hard thing to do. But with vision technologies improving, robots can now see and define the characteristic of a fruit, and their servos and motors are so sensitive that they don't crush the fruit when they pluck it. They actually pick it gently and keep it in the basket like a human being would do. Plastics and chemicals, again, is a very obvious industry where human beings cannot operate in that kind of an environment where all these chemicals might be mixed and processed. Even many Indian companies have automated chemical plants where algorithms are basically mixing chemicals rather than human beings pouring manually or turning a tap on to put something in the chemical process. The interesting thing is, without understanding what type of robots exist, there is no visual idea of what automation actually means in the industry and how sophisticated it has actually become. So let's take a look at what kind of robots actually are operating in the industry. So the most common robot that we see in most of the media images of robots are these 6-axis articulated robots. Essentially, this robot can turn on any axis and it can do a lot of activities in a different manner. So this is the particular joint where you can put in whichever appendage you want. It can be a welding appendage, it can be a painting appendage, it can be picking something, it can be attaching something to any other particular sub-assembly. So the whole idea is this arm can be used in many ways in the entire plant. Now in this particular line, you can see there is no human being inside because these robots are basically crammed together and they're doing the job which other human beings would have taken a lot of time to run on the assembly line. So multiple robots are welding, multiple robots are cutting and polishing and grinding and whatever. So whatever appendage you attach to the particular arm, basically that task can be done by the 6-axis robot. Then you have a delta robot, which is essentially attached at some ceiling or some height, and the joint underneath keeps bobbing up and down and does a job of picking or placing something in a precise manner or a precise grid which is laid out for it. So some of the examples can be seen here where it is picking and putting something here, or where over here it is cracking something and it's maybe look like an egg or something like that. Or the semiconductor example we saw earlier, where this particular Delta robot is placing a piece of chip on the circuit board which is being assembled. Another robot which we have seen a lot of times is the gantry robot. It essentially is a beam and columns construction where a robot can move in a horizontal manner or even to and fro, and any limb can be attached to it, basically to move that particular item and process in that particular manner. So in this particular example, this gantry robot is used to pick up tires and place in the warehouse where it's storing. In fact, any arm can be attached to this, and any requirement can be met where it can move across the entire factory in a linear fashion. It's also called a Cartesian robot because it follows X and Y axis movements for the robots. This is a more interesting category. I wish you can read about this and see YouTube videos. It's a fantastic thing to watch. Essentially, they're called cobots or collaborative robots. And these robots work alongside human beings in the same vicinity. So ideally, if one of these robots was in the vicinity of a human being, the weight of the robot itself will be harmful if accidentally a human being knocks on that particular arm of that robot. In fact, it can be fatal for human beings if some robot suddenly moves in an axis and hits a human being. But in this case, these robots are designed to be very flexible. The materials used are softer. In fact, it is basically aluminum, or sometimes they also use coating on top of that. In this particular example, we are seeing a robot which is working along with a human being in a packaging unit. The human being just has to monitor the robot's activity and probably do another task, which a human being can multitask, but a robot may not. Robot may be fixed to do only one thing. And even if the robot hits the person, the robot realizes that it is in the proximity of a person and retaliates on its own, rather than the human being have to pay attention that the robot is working next to them. So this is a very innovative concept, extremely expensive technology, but it can actually improve productivity of a human worker. So this is in a way a labor reducing technology rather than replacing technology. But you can imagine, if you extrapolate a little bit further, you can imagine that over a period of time, why wouldn't a human being be replaced by another robotic arm? And that's a question which any human being working with these robots is facing right now. In fact, in China, where they are automating at a pace they have never seen before, many of the employees, when they are interviewed by journalists, you can watch the videos. They ask them, "Are you worried about a robot replacing you over a period of time?" And everybody realizes it's a matter of time that their job will go away, because the company will figure out a better way, a more productive way to use a robot in that situation where the employee is right now. These are very interesting, and we have also seen them before in any of the warehouse videos where robots are used. This particular robot is shown. It's an autonomous mobile robot. In fact, any autonomous robot, even the autonomous car for that matter, which we have seen in one of our previous FOF sessions, even the autonomous car is in that way a robot, which is autonomous mobile robot. This particular one is capable of lifting a large amount of weight, which definitely a human would have used a forklift before. And you can see the space a forklift takes. You can see the space that this particular robot takes. And you can imagine two of them next to each other and carrying several different kinds of items, which otherwise a forklift will not be able to carry. In fact, you can also have clearly demarcated areas for whether humans can work and whether robots can work. So that gives you enough context of how robots are used in warehouses and how quickly they can streamline operations in the warehouse and reduce human effort. This is the most popular robot in video games and science fiction. Essentially, it's an exoskeleton robot which improves the ability of the human limbs to perform slightly heavier or slightly heavier tasks. So, for example, even in prosthetic limbs, if somebody has lost a limb, they are now trying to create robotic prosthetic limbs, which takes sensing from the limb itself to know what activity has to be done. And it can be attached to the body, and it looks like a normal limb if you are wearing clothes on top of it. But this is an exoskeleton, so this is supposed to be worn on top of clothes. So if you are a gaming fan or a science fiction fan like me, you would have seen some of these in video games, like this exosuit in Deus Ex, or this exosuit which carries a lot of weight in Death Stranding, or even this Tom Cruise movie and this Matt Damon movie. You've seen the exoskeletons that they wore in different conditions. So in this particular case, Matt Damon loses his ability to move his limbs, and he's attached to this exoskeleton so he can move his body with the help of a robot. Don't even start about this movie. So, I mean, we have seen the different kinds of robots, but how often are they used? And the metric that most people follow in the industry is the robot density per 10,000 workers. So you can see India clearly. This is data from 2017. Unfortunately, the latest report was much more expensive. I did not buy it. But this particular data point was interesting. So in 2017 report, they mentioned that the average, global average was 85 uh, robots per 10,000 workers. And you can clearly see some of the countries with slightly more aging populations, they might have a higher propensity of using more robots in the plants than using human beings, because they just don't have more people who are doing those jobs anymore. But in countries like China and India, it's so far interesting to see that the density of robots per 10,000 workers is not as high. But as per the latest average number of 2020, this number was 113. So from 85 in 2017 to 113 in 2020, there's an interesting jump in density of robots in manufacturing plants. And it's clearly the incremental investments in robotics is clearly happening in Asia, and China being the largest contributor to this. So what we saw about the first industrial revolution, followed by mechanization to electrification to automation, and automation to now having enough computing power to run machine learning algorithms, to do pattern recognition, to teach the machines how to learn about the manufacturing process and give them more tasks which otherwise a human would have done those tasks. A machine can pick and choose these tasks far more actively. Also, improvement in vision technologies, sensors, and all these tools now as part of the robot make the robot far more valuable and can work for a far longer life and tirelessly entire day without asking for a break or a shift or something like that. So Industry 4.0 is one of these imaginative ideas that people have, and some of them have actually made these plans possible. But there are a lot of challenges and myths around Industry 4.0. So one aspect is connecting every machine to a network device, and the machine can talk to every other machine and they can work autonomously. It sounds amazing in theory, but there are several machines which can be older and some are newer. Newer ones might have the capabilities. The older ones might need augmentation to become capable of that. That is another capex that the company has to make. So not every company who's manufacturing stuff is on a budget and has a margin to do all those things. So it's a long-winded trend. Although people might believe that it's going to happen tomorrow morning, but rest assured it might take a much longer time than that. Just like the 300-year journey that we have seen so far across all these four versions of industrialization. So one important factor with Industry 4.0 is we have this. So because we are oriented towards productivity, we always think that, okay, let's put a software on top of it and it will take care of everything. It doesn't work that way, because every manufacturing facility does not have the same requirements. Some of them might have a large scale requirement, some of them are small scale requirement, and each of these requirements are different, and different service providers can cater to these requirements. So one size definitely doesn't fit all, and that's the reason you cannot have a holistic view of Industry 4.0 the way some of these reports try and communicate. What we are seeing is, like I mentioned, older technology working alongside newer technology and software tools not being synonymous to each of them. You don't have integration at the scale at which you can have in a software-driven environment. You can connect two softwares with APIs very easily, but there's no equivalent of a hardware API you can suddenly plug and play like we connect a software. In this particular case, the software does not actually define the hardware. In fact, the way the hardware is constructed actually defines what software can be used to make that hardware work in the way. So what PLCs can be used, which DCS system is already installed, which SCADA system is being used by the company. Can you replace some parts of it? Can you replace it in an entire package, or can you replace it in piece by piece manner? So all those things define what softwares are actually going to be used in a particular plant. In fact, we are so spoiled by the whole aspect of software as a service that the Gmail app, if you use in the enterprise, and a Gmail app you use in your personal phone, will be almost the same. You will have all the same features in it. And we are so used to standardization of software, we actually assume that standardization also applies in the hardware environment. But in hardware environment is a highly customized and highly purpose-built environment with very specific cost and cost constraints in mind. Whereas in software, if some email feature is not available, which was there in Outlook, but it's not in Gmail, we wouldn't cry too much. We will say, okay, it's fine that one feature is not there, but the email works just fine. We accept standardization far easier because the cost of accepting it is much lesser for us as users. Whereas over here, the cost of customization and standardization are completely different. So different planets altogether when it comes to a manufacturing unit. And also one interesting question that always comes to our mind, that is this industry also moving in the same direction with which software industry was in the 1970s or the 80s? Because at that time we had an era of customized softwares. People used to build customized software that worked on standardized operating systems, and they used to run these softwares independently of each other. And over a period of time, the standardization in the software industry improved to the extent that everything became a cloud app that we are using nowadays. It can be used from a phone, it can be used from a desktop, it can be used from anywhere. But can the same thing happen in the hardware industry remains to be seen. And probably there is a lot of opportunity in this space where new companies are coming in. So in the beginning, I mentioned that there's a time element to this whole discussion as to why are we discussing about automation today. And I think one book which primarily drove me to make this presentation was this particular book called The Technology Trap. It's written by Carl Benedict Frey, the professor, I think, at Princeton. And this book has a very nice Diego Rivera mural. In fact, Diego Rivera's murals are quite amazing. You can just go online and check out Diego Rivera's industrial murals. And he depicts the class struggle of capitalism and socialism. The whole idea behind capital versus labor is represented very well from the artwork. And the book tries to address the same point. And I was very surprised that somebody thoughtfully used the Diego Rivera painting to depict the topic. So this book covers interesting data points, tries to dig into public records and government records, and tries to find the whole struggle between capital and labor that we are seeing today. And at that time also, there were few people who were incredibly wealthy. The wealth inequality was significant. And we saw that at this time, the creation of the middle class was actually started to happen. And the 3 centuries of information that we already have on this topic, it tries to assimilate them in different boxes in this particular book. Another interesting aspect I loved about the book is various governments have tried to address this over a period of time. It's not a topic out of vacuum. It's not come suddenly. The cyclicality of this topic is also quite astounding. That every 25 to 30 years, this topic comes into the public domain and people talk about it. And this book gives a very interesting dimension to the previous policy actions taken by other governments, other local governments and cities and the countries, and what are the outcomes of them, and how the debate between labor replacing and labor reducing technologies took over in a long period of time. It also interestingly dwells into the now popular, or probably a topic which again becomes cyclically popular over a period of time, is the idea of universal basic income. As if what happens if most jobs are gone, and who will take care of the people? Essentially, can you reskill them at the right pace to absorb them into the existing system of work, or these people are completely displaced from their jobs? And the interesting aspect about what we saw, mechanization to automation over the past 300 years, is depicted very well as to what happened in local industries, what happened in specific sectors when these things transformed those sectors at that time. And one of the interesting conclusions that the book has, which is slightly slightly very obvious, it's not a mystery, is that the role of education in all these activities. So if an employee decides to educate themselves in a better manner, in some other technology or some other skill, they can be repurposed for some other job. And hopefully that job doesn't disappear while they're educating themselves. So the whole idea is education doesn't catch up with the idea of technology replacement. And that has actually affected generations of people. So the whole world celebrated industrial revolution, the creation of capitalist economy, but the people who were displaced at that time, in that 70-year period of the first industry 1.0 period, they actually struggled and suffered a lot and fell through the cracks of the economy. But one particular aspect which I found is amazingly described in this book is, despite all this, despite the creation of different kinds of labor requirement, despite the growing of industry to such extent, we still find labor shortages. So at one side, we find there are people who are wanting to work and are not getting employment. And on the other hand, if you just Google the word labor shortage and put the country's name on top after that, you'll actually see so many articles about specific industries not having enough labor. In fact, if you look at the immigration sites of some of the smaller European countries, which are part of the European Union, you will see there are jobs of electricians, plumbers, cab drivers, all these people from all nationalities can come to the country, just land there. Language barrier is not important for them. Just start working if you have the right skills and you're certified to be one of those people. So this one, on one aspect, there is a mismatch of this particular idea that there is not enough work to do. In fact, there's plenty of work to do, but there's a problem of skill mismatch. And this book covers all these topics quite well. So although I've given you a summary, probably would have covered 2 pages in that book. If you read the whole 300 pages, you might get a better idea of what this conversation has been in the past 300 years. Again, a very interesting book written by the same author. So Martin Ford in 2017 wrote this book called The Rise of the Robots. And this is a very alarmist book. This is the book which scares you to hell as to whether all our jobs are going to go away. Even white collar jobs are going to go away because AI and machine learning will displace everything. So imagine us in the industry, in the financial industry, who look at companies and study businesses for a living. Uh, Before, there were these tools like screener.in or something like that, which could give you the entire template. We used to take an annual report, piece of paper, annual report, put in the numbers in Excel, or just draw a table on a piece of paper. We did not have a computer at that time, and just do ratio analysis manually. That job has been replaced completely by a computer. Now we can just type a company's name, the entire last 10, 15 years, whatever data we require is available to us on the fingertips, and we can actually learn immediately if the company is worth looking at or not. We don't have to spend a single minute reading anything or spending any time doing that. So a significant labor reducing technology has been come. But imagine the people who used to put in those numbers, those jobs are lost. For some reason, they are reduced in number to that extent. So Martin Ford raised a very alarming, wrote a very alarming book in 2017. And as if he realized that, okay, it was too alarming. It was on the other side of the spectrum. He came back in the middle, became a little normal in the curve and said, okay, I will write a book which sensibly talks about the adoption of machine learning, AI in day-to-day life and in industrial life, and talks a lot about what is happening in the industry today as how automation is proliferating in different aspects of manufacturing. Again, the father-son duo, Daniel Richard Susskind, wrote these two very interesting books. This book is, I think, relatively new, and this one is 3 years old, I think. Now, these two books talk about the same thing, but from different points of views. On one side, this is what we discussed in the entire presentation today about the role of automation and what happens when there is no work. So there's a socio-economic angle to it and an industrial angle to it. And in this book, here it talks from the point of view of skills as to what kind of skills do you really require if your profession is changing over a period of time. How do you upgrade yourself? How do you learn what new trajectory is in that particular profession? And the whole idea behind creating professions. So is it normal to have multiple professions? Because when the world is full of doing so many things, you can actually pick up different skills and you can learn different things and become a person proficient with two different activities that you can do or two different skills that you can use. So vastly different books, one from a creation of skill, either educating yourself or educating through a formal mechanism. And on the other hand, now that you have education, do you really have work to do? And these two books sort of complement each other very well. And as if the whole AI and the ML conversation was not too confusing, this book came at the right time. And Melanie Mitchell writes about what are the true limitations of AI. So sometimes we extrapolate too quickly and say that everything gets automated immediately. But then she uses examples from the industry as to what actually happens when you're implementing a automated system, even in software. So how does machine learning actually work? How does AI actually work? How can it be used in an existing process? How can something be replaced from a manual process where intelligence is used of a human being to an AI process which is fully automated and learning on its own? And also the whole concept of autonomous robots in factories in day-to-day life around us. So at the moment in India, we don't worry too much about a car suddenly driving past us, which is an autonomous car, which has no driver in it. But there are certain cities in the world where there are autonomous cars on the road, which are driving alongside normal cars, and people have to worry about them. Not worry maybe, but they have to be aware that these cars are around in their vicinity. And imagine the taxi driver in that industry, in that particular city, who will be seeing this car every day and imagining whether this car is going to replace that person's job in the next 10 years. It's an anxiety people live in real life. In our country, we have not reached that stage yet. But this book quells a lot of these kind of anxieties that we have regarding the pace at which AI is used in day-to-day industrial life. But a very heart-wrenching book, I think one of the last books I would like to recommend is a book written by Washington Post journalist Amy Goldstein. It's a book about a town in the US called Janesville. And this town was reputed to have one of the oldest GM plants. Now, GM went into restructuring during the financial crisis, and because of which the particular city lost the plant, and the plant never restarted after the company came back on its feet. Now, if there is a significant employer in that particular plant, what happened to the ecosystem of that community? What happened to the economics of the community? And how did the people fare? So it's a story of people, how they survive when they're suddenly displaced from their jobs because of either obsolescence or the plant actually failing, the business actually failing, or not having enough options to reskill yourself. This is probably like a tier 3 city when it comes to comparing with the Indian context of a tier 1, tier 2, tier 3 city. And people don't have that kind of upward mobility like people have in the cities. They cannot suddenly switch jobs when they want to. So what did these people do? How did the town come back on its feet again over a period of time? And this is a story over a long period of time. The journalist has meticulously noted down with specific personal examples. It's a fantastic book. It is a book worth reading from the point of view of what happens if there are no jobs, actually. Although it says it's an American story, but I think it applies to any community where suddenly jobs are replaced by either technology or by obsolescence or the business failing. So again, I came to clickbait. Implications for India. Well, I don't have answers, but I have questions. Probably all of you can answer. Some of who have also read about these things. So I think one interesting thing is from the technology trap book is that any policy change you make from a labor policy point of view has several repercussions across all the industries who employ labor at scale. And second order effects are not really obvious when the policies are drafted. Some of them can be imagined, but some of them can actually be seen only when the policy comes into action. So with new labor policy on the annual being implemented, it's very interesting to see what will actually happen. Will actually scale up the process of increasing employment for people. Will it enable reskilling, or we don't know what happens? Or will people be forced to go to automation and not have enough labor? That's a question that remains to be answered. And it's a very expensive question for a country like India, where we have more people than we have robots right now. Also, if you learn from China, some of the automation that is happening, the point I mentioned about wage inflation is quite real, where electronic manufacturers or large manufacturing units are actually implementing more and more robots in an incremental fashion across all their plants to replace some amount of labor that they are using there, manual labor they're using there from this wage inflation point of view. So in the last 5 years, there was a metric that some of the electronics plants have actually seen 25% wage inflation, and there is no way that their margins have grown in that much fashion at the same time. So there's a competition from other players to productively manufacture stuff, which is what we saw, that there is not operating in a vacuum, they're actually operating in a competitive environment. At the same time, you cannot tolerate the wage inflation where a different city is competing with you at a different cost structure. Also, we worry about comparative advantage from an economics point of view. Uh, so the one interesting point the technology trap makes is that the business model or thought process at that time was to look at labor differentiation, like different tasks are given to different people and their tasks will always remain. That was the whole idea when Adam Smith wrote his book. But if you look at the modern way of looking at the economic system, one thought seems that the jobs are actually fungible in different areas, and you can actually have a cheaper manufacturing unit somewhere else, which David Ricardo's idea of comparative advantage scaled to a completely globalized manner with very efficient supply chains. And what happens when supply chains get disrupted, we saw very vividly in the last year, and how the comparative advantage can actually shift quite dramatically between countries and companies. So this one question remains, that what comparative advantage does India have? So most of the time we debate that labor is the comparative advantage we have, the low cost of labor that we are having in our country. But how the utilization of that low cost of labor is, we have only seen at scale operate in some manufacturing companies and at scale in the IT services industry, but we haven't seen at scale in all kinds of manufacturing. But it remains to be seen. Also, with job losses and people not being skilled to work in manufacturing industries, the services industry starts ballooning. And it can be all sorts of services. It may not be services which are specific to, say, hospitality or other kind of services, but it can be even a delivery partner on one of our delivery apps is a service economy job. And the service industry grows quite dramatically when you don't have localized jobs for those people in the skills that they have trained themselves in, or whether the skills are actually relevant or not. So one trap that we saw in the technology trap book was the idea of education helping people. But if you actually game that system, if you create people with inappropriate degrees, which are just labels on their CV, but not skills that they have learned actually from their work, then those educational benefits disappear immediately. And lastly, when we say that manufacturing has to move to India, the China plus one idea, what are the second order effects of that? What do we require? Do we have enough land? Do we have enough trained people? Do we have enough power capacity? Do we have all these things connected with good supply chain? All those things, all those questions come up immediately the moment we start seeing that manufacturing renaissance is going to happen in our country. So I have actually more questions, and feel free to comment on them in the Q&A session. So this is the last slide of the presentation, and just wanted to thank all these resources from which I learned. So the company filings and the history of some of these companies are actually quite dramatic, especially the robot companies like KUKA or companies like Fanuc. They have a fantastic history of how they have innovated themselves to different technologies. Also, the books I mentioned have different dimensions of the same topic, which cover different aspects. And I think they're worth reading or at least skimming through once. If you go on The Compass, it's a podcast by BBC. Daniel Susskind actually made a Future of Work series where he actually interviews people, and it's an input for some of his from his books. Basically, he talks to those people and they record their interactions. And these are very low-level service jobs, like people who are working at the retail checkout counter, and their jobs are being replaced by automated checkout systems. So they talk about Amazon's famous automated checkout experiment, where the camera just scans your putting a product inside your bag, and that's it. That's your checkout process. You don't need to actually give the product to a person. They will scan it and you have to pay with a card or something like that. Automatically fulfills the particular transaction. Again, Industrial Revolutions on YouTube is a 4 season long series. It's fantastic. You have to watch it because it gives such a vivid context, and he goes back to the towns, goes back to the locations, and uses a lot of local data to explain how this particular industrial revolution came about in the next 300 years. Another very interesting show on BBC is the Genius of Design series. It's a 3-part series talking about the importance of improvement in design thinking over a period of time, which led to creating different manufacturing processes. So one is designing the product, but also the other aspect of design is designing the process to create the product in a more efficient manner. So these two aspects got married somewhere in the last 150, 200 years, and which allowed us to see industrialization at a scale across different industries. ABB has started a new podcast about robotics. It's worth listening to. And another podcast called Robot Brains. This host basically calls different people from the robotics industry who are at the cutting edge of doing something in that area. And he talks about the implementation and the possibility of scale in that area. So I think some of these resources, along with the books, will actually give you a very good idea of what industrial automation actually is about and how it is scaling across the world. Thank you, and I'm happy to take questions. I think we'll take questions from the Zoom audience first. If you can just ask one by one, it will be helpful.
Thanks, Ronak.
Hey, my pleasure.
Hi, Ronak. This is Kirit Modi here.
Hi.
Thanks a lot for a very, very interesting futuristic presentation.
Thank you.
I only have one comment to make. I'm an industrialist. I run packaging units all across India. So I'm giving you my perspective. With the rigid labor policy, what we have in India, and the falling cost of capital and excess liquidity, there is definitely going to be move towards the more and more automation. So that will definitely impact the the employment policies of the government and also the skilling programs. So that dilemma needs to be solved. Otherwise, we will definitely have a problem ahead.
Sure.
This is my comment.
Thank you so much for the comment. So if anybody else on Zoom doesn't have a question, we will take questions from the live audience, which is actually a privilege to have people attending the event live. Anybody has a question? I can pass the mic to you. Well, I think I was very vivid and lucid in my presentation, so there are no questions. Hey, there is one. Yeah, please go ahead.
Hi, wonderful presentation.
Thank you.
I just had one question. I had one question. What, according to you, you mentioned there are 3 basic categories: end-to-end, specialized, and integration. So what, according to you, is a better fit, or where to be if you are trying to own a business, or which is a more interesting part, whether it is an end-to-end customer service, specialized, or integration?
So I think from the study of these companies, all of them have done well at different points in time. At one point, when different companies did not have resources to scale their innovation to a level where they can reach the global scale. They were localized players, and the end-to-end companies benefited a lot by that vacuum. So a substandard product or maybe good enough product also was being used in the industry. And because this particular area is very sticky, they don't suddenly change the technology they're using in the plants. End-to-end players benefited because of their long operating history, large cash flows, and global supply chains. So the smaller companies are now getting recognized in the past 20 years because they have suddenly been recognized by the world that this particular item or a component that this company is making is far superior than any other end-to-end player can make. And because they realize their limitation, they also created a way to plug into any system that is actually being used right now. So that plug and play way in which APIs are using software, most companies figured out that if our components can be used with other components, then it is better for us to scale. So for example, a company like Keyence, who is a leader in vision technology, they actually have technology. So if you look at the number of SKUs they have, it's like thousands of SKUs they have for very specific vision related requirements. And one can be laser guided systems, one can be camera systems, but the software that can read that data can be generic, can actually have their own technology being used or some other technology, but Keyence provides the hardware and they make money and margin on the hardware and the tool. So it's basically a company who provides design tools also, where companies can adopt these technologies and learn a better way how vision can be used in their automation processes. So these are unique business models which have come up afterwards, but only when the product's recognition has spread over a long period of time. That took 20 years to build the kind of reputation that they have. Otherwise, the end-to-end players have done well historically because they have global scale and they are like a choice which you cannot fail at. If you have the money to employ them, people probably choose to employ them. If people are on a shoestring budget in trying to automate some small process, they will do incrementally by using a patchwork of systems in different areas of the factory. Very rarely you will file a fully automated factory setup from ground up directly. So when Tesla, in fact, it's a very interesting example. They famously had a very fully automated process. In fact, in 2017, I think, or 2018, when they had a production issue, Elon Musk gave an interview and said that we are in a production hell right now because we over automated our entire factory. So we said that humans are good at certain tasks. We should have put humans in that system. And eventually they fixed and the production volumes then went up over a period of time. But it's a painful process. Manufacturing is not like software. You cannot just plug a system off and plug a system in. In fact, in software also it's very hard if it's a critical function you're running. But in manufacturing it multiplies because capital requirements are significantly larger and it displaces your immediate ability to do the work. But I think all different models have worked well. And in fact, if you see companies from tracking point of view, the discrete companies are actually better to track because you can learn about different parts they're selling. The global conglomerates, everything gets washed out into the general balance sheet. So you don't know where the money has come from, who is making more money. You rely on their disclosures and honesty about how these companies are run.
Thank you. Thank you so much.
I don't know whether you touch on, since we're having more industrialization, doesn't it mean open to hacking? And in terms of, is there some thought process on that? Or because another chip which is running the.
So if I understand your question correctly, you are saying, are these systems open to hacking or security issues?
I'm sure that somebody is definitely trying to make a system which is.
Yeah. People are hacking nuclear plants. So this is not, I think, far away. So people can hack these systems. Any chip or any PLC which is linked to any network, and the network can be, if you can interfere in the network in some activity, you can reach that network's endpoints, can definitely hack these systems. And these will be primitive softwares also. So there will be enough backdoors left by the developers that they wouldn't have had the capacity to patch them, but somebody will identify them. And of course, they're hackable. In fact, there's a nice movie on Netflix called Black Hat, where a hacker actually hacks a pump in a mine. He's shorting a commodity, I think tin, and he wants to flood that tin mine. I've revealed the plot to you and ruined the movie for you, but it's an example where PLC gets hacked from a backdoor which was available.
Yeah, Ronak, my question is, do you see any Indian company or startup who is working on this field by making robotics or no? Because I've seen in your entire list all the overseas companies like Germans or US or Japanese companies where they are in the listed thing. Which Indian company do you think that they are working in this field? Because now Modi government is focusing more and more on manufacturing, making India as a manufacturing hub. So obviously the possibilities of this kind of business is very, very good in it as far as India is concerned. So in India, do you think any listed or unlisted players are there into this field?
So there are several unlisted companies which are very small at the moment with doing specific things. So one company I remember offhand is Gridbots. Gridbots, Gridbots.
Okay.
So Gridbots is a company that makes specific robots for specific tasks which can be put into any factory, and they work with other technologies at the same time. So it is one company I know of which is at scale and which has raised money and they are doing well.
Okay.
There might be several other companies in niche areas. Some might be in automation, some might be in integration. But in listed space, I don't know. I have not found too many companies talking significantly about their revenues coming from this activity. Might be a small percentage can be coming from this activity. Like the engineering R&D players or system integrators, they can provide some role in this situation. But I don't know at scale who is operating from listed companies. I haven't come across any.
Okay.
In fact, most of us are users. So like in semiconductors presentation, I had said, we are majoritarily users of all these technologies.
Yeah.
And the companies like ABB as an Indian unit, KUKA as an Indian unit, Fanuc as an Indian unit. So these companies are operating in India also. So it's not like India is a remote market. In fact, auto industry has been relying on automation for a long time in India. So all the global companies have their Indian subsidiaries and they operate over here and provide the same service that they would provide anywhere. So the Indian company has a two-pronged task at hand. One is to compete with the existing players or create a product so different that it can be immediately implemented without using this technology. So for example, in China, some remote villages, the landline telephone never reached, but they have mobile phones immediately. The first device they had to communicate with the mobile device, and they started using that. So there might be some implementations where you can bypass the existing technology track and create a different track for yourself, and you then start becoming a leader in that track. But I don't know at scale who is doing it. So anybody else in the audience might be aware. Please tell us.
Thanks.
I think, in fact, most engineering colleges, the final year project is to create a robotic car. And I think that is where the robot passion ends after a while. And people probably don't understand that automation and mechanization is such a large field that the engineering skills can be used there instead of joining an IT company. I'm just kidding. Cool. If there are no more questions, thanks so much for attending. And thank you for the audience in Zoom to spending your precious time with us. And we're ending the call. Thanks.
Whenever things got rough, I always remember what my father used to say.
Running a business does test a man, my son. There are ups and downs, glorious highs, and sometimes a low that leaves you feeling defeated.
The character of a man and the character of a business are not very different, are they?
Yes. But when the chips are down, we must stand up, dust ourselves off, and motor on.
Volatility. It's a funny thing. It makes you question yourself and wonder if you've made all the right decisions.
Sure, you can question some of your decisions, but stay steadfast on your goals.
Dad always said, there are no shortcuts and no quick profits.
There are no free lunches, are there? There is only one
right way.
At PPFAS, we think like Rahul and his father. That volatility is a fact of running a business. And buying equity shares is like owning a part of that business. We use value investing principles to manage your money. This means we invest in the right businesses at reasonable prices and for a longer term.
PPFAS Mutual Fund. There's only one right way. Mutual fund investments are subject to market risks. Read all scheme-related documents carefully.
Mutual fund investments are subject to market risks. Read all scheme-related documents carefully.